up, guys? It is hot. Long day already, and we will extend it and make it just a little bit longer. Got a few more things I gotta get done. Trying to sort out and find something I think I got, but sometimes you know what you get for thinking. Gotta make sure I can find it real quick. So I am I guess I'll show you guys some stuff. So pull this out. One, two, three, and four. Alright, so in case y'all don't know what this is flat braid. Flat braid has an equivalent, hang on, let's go ahead and quieten this up a little bit. Flat braid has an equivalent size per gauge for the size that the wire is, and also based off the quality that the wire is. But there's some 1/2 inch flat braid, 3/4 flat braid, 1 inch flat braid, and 2 inch flat braid. In this particular application, I'm going to be using 1 inch. You'll kind of see and notice that if I try to use a 4 gauge connector on 1 inch flat braid, there's just kind of a disconnect there. It's just not quite enough to fit. I can maybe make it work, but that just kind of gives you an equivalent gauge. Now, equivalent DC gauges does not necessarily mean equivalent RF gauge, so don't get confused. Just because somebody talks about using flat braid in one application does not mean that's an absolute for another application. So don't get too confused about it. The higher in frequency that you go, the more skin effect comes into play. At low frequency like DC, which is 0 frequency at all, or jumping up to AC, which is 60 hertz, which is very low frequency. It really doesn't have much of an effect, so you're not really looking into stuff like that. When you jump up much higher frequencies, up to say 30 megahertz or so, it has much greater effect. What that is it cannot penetrate, or any sort of real current or voltage doesn't penetrate and use the entirety of the wire. So if you use, I don't have any sitting here. I got 4 alt and bunch of other wires to show you, but if you use a solid wire, say this big around, it doesn't necessarily mean it's going to be any better than braid this big around, even though that wire has much bigger current. It's not necessarily a bag, it's just I'm actually not selling it. This is what I actually use to build. This is my 1 5/8 direct feed. This is my 7/8 direct feed. This is my 1/2 inch direct feed, or 1/2 inch flex direct feed, and this is my 1/2 inch direct feed. That's just what I use for doing direct feed. You can use whatever you want. What I use is equivalent gauge for each one. I'm using a 1 alt terminal with this 1 inch braid for my 7/8. We're about to be building here in just a minute. Get a little bit more length out of this. I showed y'all a little bit earlier about how much 7/8 can actually bend. It's not small by any means. I'll give you an idea of how big it actually is. So not necessarily small, but it's also not necessarily a huge loop. You can run it down into about a, I would say about a 28 to 30 inch circle or so. So rotor loops are not very hard. Shipping is where stuff gets difficult with stuff like this. So don't really get, I got some people that's all worried about running 7/8 and building a loop for it around their beam and stuff like that. Don't get too into that. I mean, there's really nothing to be worried about. So I don't know why I'm doing this. I usually cut it back anyway. Whatever. Actually, I didn't do that. Actually, I just did this just a few minutes ago, so there's no point. We'll cut it back in just a little bit, just because I can. I did not bring my fun little tool that I showed you guys how to cut 1 5/8" with. I've never tried this. Let's try it. I've got extra wire, so I just want to see what it can do. Not bad. Alright, so what I did right there was just clean the connector. Whenever you cut with specific tools, what it does is it leaves shavings. So I just wanted to cut with that to see how it cut, to be honest, because I was kind of curious. It's not that great of a tool. I wouldn't recommend it for other use. I just needed to go ahead and knock that end off real quick. I'm always apt to learning something new and seeing something. I wonder if I've got something in here, in my little pile over here. The one thing I don't have that I should have is a hammer. I might have it over here. Hang on. Oh, I do not. Y'all see a few addition to my collection back there. I got some more batteries back there, just added to the mix. I got a lot of stuff going on over here, so excuse the mess, but there's a lot of stuff coming soon. Here in the next month, we're gonna add a bench number 5, and that bench number 5 is gonna turn into number 1 bench. But still a little bit away, so let's enjoy this chaos while we got it. See if it'll do what I need it to do. Oh, and those of you guys told me to get my vise. I got one. Alright, so what I'm doing here, it's nothing really special. One, I'm pulling off this Velcro off of it. It's just one of the vices that I got. I dug one out for you guys so you don't have to see me jerry rigging up some stuff. I don't mind doing it because it works out pretty neat. See, look at what I'm doing to the terminal. I'm just flaring it out. It really doesn't matter how pretty it looks in the end because I'm going to heat shrink it and cover it up. It'd be nice if you had a tool. Probably the best tool would be, I'd say, a rubber mallet or so. Probably the best tool. I've got a rubber mallet, but in case y'all didn't know, it is on bench number 1. So all I'm doing is just cutting it to an oval. I'm not knocking it flat or anything. I'm just knocking it to an oval. I have done in the past. I have flattened them completely. You can do that. It really doesn't matter. It's not super critical as far as that goes. If you're tugging on this right here enough to give it any sort of problem, yeah, of course you can put it in the vise. The problem is whenever you put it in the vise, the first piece of that oval crunch down. The outer parts of the oval will not. So if I do that, I'll kind of show you. You can kind of try and get away with it right here. If I go low enough on it, it won't do it too bad, but you can kind of see what's happening. But that's just kind of an idea. Now I can show y'all my other soldering method. Y'all haven't got to see this one yet. It's probably my most common method for most of what I do. Figure I'll just show y'all while I'm here. I figured might as well, since you told me to put it in the vise, so I figured I'll show y'all this method anyway. I've showed y'all other methods. All those other methods still work, and they're still just as relevant, so don't like think there's, oh no, this is the best method ever, this method replaces all other methods. I mean, what you're doing is getting a good electrical contact to your wire. So the goal is to make sure the wire has a complete bond with the solder. Whenever you do a crimp, you're getting a good mechanical connection to the wire. So at this point, all I'm doing is taking, I mean, you can do it whichever way you want, but what I'm doing is kind of cheating. I've got two ends of the wire, So what I'm going to do is just take both the bottom end and the top end and stick it in here. I don't like frays, so what I'm going to do is go ahead and just cut that little bit of tail off so I don't have to deal with all this extra frayed mess. Maybe y'all can see what's going on a bit. Oh yeah, you can. I mean, I've tried every idea known to man. Or excuse me, let me correct myself. I have not tried everything. There is always something new to learn. But I have tried many methods, vise being one of them. You guys seem to like the idea of me getting a vise, and I mentioned having a vise, so I figured I'd show y'all the vise method now. Vise method is basically just an extra hand to help hold the wire, and all you're going to do is the same concept as the others. You're going to heat up and wick the wire in. So the biggest thing you got to watch out for is make sure you're actually heating it up properly. If you're not, then it won't wick right. Oh darn, let me show y'all another method. Hang on a second. Before I get too into this, I want to show y'all something. Here's a quick little tip for you guys. It's just a little mini mix. Any set of crimpers that you got, as long as they're at least half decent, will have a nice little tooth in them. You can use that tooth to just bite into the wire, or into the terminal, any place you want. It really doesn't matter. All you're doing is just really making other people happy and getting a mechanical bite into the wire itself. So all that does is just make sure that when you're tugging on the wire, it don't pull out. Of course, I'm not going to touch that one because that one's very, very hot. So, watch what you're doing. I'm just moving this so I can crimp the other side. This is just a quick and easy and simple little crimp method. This is not a full crimp. This is just a little, just a press, just to hold it in. I wouldn't even call it a crimp. The reason that it comes into benefit is just for those guys who's not very good at this, and all of a sudden you're working on the wire and the wire falls out. Just a simple little setup. If you look, well, y'all can't see that very well, but what happened is there was a nice little bubble on top and it pulled right on down. That tells me that the solder's wicking the way it's supposed to. So bubbles on top and pulls on into the wire. Nice and bubbled on the top, and you look, and there it goes. I can usually be a bit cleaner with this method, just because I've got more control over it and it's closer to me, but can't quite get everything, especially whenever I'm on the other side of it. So I saw that little bit of resin come up. All I've got to do, clean the resin off and then pull the terminal off. And the biggest key whenever you're doing stuff like this, I did this for a reason in the past. One, make sure it's not too hot for your hands to handle. I can handle it. It's not really that big of a deal to me. And if it's hotter, just go further down or get some gloves. Just do something. Don't burn yourself over a little ground strap or a direct feed connection or something. Alright. This customer asked for a specific length, so all I have to do is just match his length request. Then I'll be complete with this. It's not critical. There's some people out there that think that something's going to make an awful effect on your performance whenever you're working with something, but I've literally seen some crazy stuff that's a lot worse than this, and it still worked. So don't get too discouraged whenever you see something that looks off, or you think, oh no, that guy must have messed this whole setup up because he did such and such, such and such. Some mobile crowd guys will say any ground strap or any direct feed connection longer than 2 inches is a problem. Some of the base station guys would be like, well, I've used 2 foot before. So don't really get too into that stuff. What happens is you add what's called inductive reactance to your system. You have to cancel it out with capacitive reactance. Or, depends on which situation you're in. Like, say if you run a mobile, like a quarter wave stick, you have capacitive reactance. Say the reason these half wave antennas exist with a capacitor in, or excuse me, not with a capacitor in, these quarter wave antennas exist with a coil on them, is trying to cancel out inductive reactance. So, alright, so we'll measure this one real quick. Oh, and this is what we're doing. This is LC number 2, I guess, for this. There's LC, that's what is going on here. In case y'all are not familiar, I will show you. Here is the comparison. There it is. Oh no, y'all can't see. There you go. There's LC right there. There's 7/16 DIN right there. And there's the PL259 right there. So, in case you guys are not familiar, kind of see what's what. LC is a good connector, does a good job. It's a bit higher power handling than a 7/16 DIN. 7/16 DIN's nice.
Daddy.
Yeah, sit down. If you don't watch. Sit. Alright, 7/16 DIN's nice. I got a chained A watcher. Hello. Say hello to Facebook.
Daddy, guess what?
Hush. No, not right now. I'll talk to you about it later. No, I'll talk to you later. Well, he's about to hear a story, guys. Alright, so moving on. Alright. I thought I had me a little helper. I was about to have me a little talker. I'll talk to her in a little bit. Alright, so let us finish. This is what he requested. He wanted a specific length. I gave him what he wanted. From here, we're just going to work out the bond on this. I guess I could show y'all with a vise, but there's not really much point. I suppose I'll show y'all with the back of the vise. Maybe. Nah, it's just in my way. I do this too much this way. So you could use the vise, close it up. I want to try to show y'all a few more methods. And the reason I'm doing this is not because I need it, but because not everybody can hold a wire, put it in the right spot, line it up, and make it work on their own. So here's your little tool. Biggest thing we'll have to worry about with the vise is, one, very simply, the vise popping loose. It's been a minute since I moved this one around, so I had it fixed in a position on the end. Alright, so see if we can do this so you guys can copy. I will try. See, what I'm doing is just compressing the wire, trying to hold it in one place. If I can get enough compression on it without it popping out, which it may, we'll just do it this way. I'll show you all this method. So you can compress it sideways, or you can just hold it together with your hands and then lock it down right here. What I'm doing is just keeping it in a specific position, clamping the very end of the wire. And see how it's nice and tidy right there? It's tight on the end. The wire is much wider than this right here. You can see it's almost at least a good 1/4 inch wider than that. So all I'm doing is just clamping it tight. And then I can kind of cheat and use whatever tool I want. In this case, I'm using a soldering iron. Soldering iron would be the best for smaller braid. When you get into larger braid, you can kind of get away with stuff, but smaller braid kind of take a little bit more care to work with stuff, because you can char the end of the wire, and when you get char it and you get a bit of soot on the end of it, what will happen is it won't want to bond very well. So that's where your trouble comes in. So the reason I bond the end of the wire, very simply, is one purpose: to make sure I don't have a bunch of strands sticking everywhere and irritating myself. You could probably work with it alright without bonding this, but there's another purpose too. One, it connects the back of the braid with the front of the braid into one piece. That allows you to wick heat much faster into the braid, and also work from both sides on the braid. So when you're trying to bond braid to copper, you need as much heat as possible spreading everywhere as well as possible. Not just heat in one little spot and having a terrible bond. So it's just for a more even coverage. I haven't really been watching and seeing if y'all are telling me anything, so I apologize. I'm apparently a little talkative today. But this is just another method. The biggest thing you'll have to watch out with this method is, even though that a vise does not necessarily wick heat as well as copper or anything else, it will most certainly make it harder for your copper strap to bond or heat up, just because even though it's not necessarily copper, silver, or gold, or some sort of high heat conductivity metal, or high thermal conductivity metal, that's got very good thermal conductivity, it still wicks heat no matter what you try. So I can cheat now that I've got this outside of it heated up. So all I'm going to do is add just a little helper to the jacket. Now you can get about a 300 watt pencil and make it work a little faster with that. But I like Weller, and but I like a specific type of Weller, so it kind of prevents me from getting a plug in the wall unit. I've got a power supply and everything else. The biggest pencil they make for my specific station's a 120 watt pencil, but it's a little bit more of a precision pencil, so you can get some big fatties if you want, but it's not really something I need. I may eventually. Also, you can get those little trigger ones. Really all you're trying to do is just heat up this connection. It doesn't matter how pretty it looks in the end, because all it's going to do is be bonding to the corrugated copper, and then beyond that it's going to be covered with heat shrink, and hopefully, if you did it properly, sealed. So don't get too OCD about this stuff. It's hard for me just because I am particular about stuff. I want the solder to wick in a certain way. There we go. Now it did what I wanted it to do, and get a little bit better coverage over here. This is a vice grip method. This vice grip method does take longer than just holding it on the regular side of the bench. I want to kind of make y'all aware of that. So anybody who decides to try to take the easy way out, per se, then whenever you do that, you do actually increase your work time. And just a fair warning, I'm sure somebody's going to try it at some point in time, but I'll just go ahead and stop you now. Don't use a plastic little vise or a little clamp or something like that, because all that's going to happen is that plastic's going to melt faster than you know what, and you're going to have a big old mess. So don't be trying to circumvent the metal vise if you do plan on using one. Alright, there you go. See, it just holds it in place, keeps it small. I don't have to worry about something like this happening, it fraying out like that, and having to deal with it. Alright, so it's got my braid prepped, so I can go ahead and, I suppose, do the split feed side for you guys, since you guys are here and y'all already invested enough time in that section. Also the LC later. Alright, okay, let's see. Here. Just stripping the jacket back. No real rhyme or reason to that. You can kind of cut it with whatever you want. I use a knife. Alright, and I've got another tool I guess I can show you guys. I mean, I'm just showing you that this is not all cut and dry. You can really do it however you want. This is not necessarily the easiest method right here. But it is a method, so I like to change it up, especially if I'm doing something that I'm familiar with, so I might as well just show y'all something new. First things first, I just measured the width of my braid, so that determines where I want to cut from. So from here, I'm just going to cut this outer jacket off. The way I do this is just try to get it secure in some way. I could put it in the vise, but corrugated copper, vise, oh, it's getting loose, let me tighten it up some more. Probably not the smartest decision, so just letting you guys know. So what I did there is literally just use the vibrating tool, basically just a multi-tool. Just all it does is vibrates, it doesn't cut or anything like that. And just cut a slit around the end, and cut a slit around the other end, cut a slit all the way around. I did it with 1 5/8, but that's just something to show y'all. That's a method y'all can use. You can use a knife, but it's going to get dull. You can use, and then of course you can go to your handy dandy trusty Dremel. Safety glasses, yeah, definitely a good idea. Anybody who's working with this stuff that's not using safety glasses, you're kind of dumb, and that includes me. So I've done it on a few of these videos when I didn't have my safety glasses. It's always best to be better safe than sorry. The last thing you want to do is being the one known for losing an eye when working on something. So you never know. I had a cousin of mine who literally was swinging on a swing, and the swing broke, and it was over a valley, and he fell off in a ravine into some briars, and a briar went into his eye. As some of you may know, that's extremely dangerous, and you could easily lose an eye when that happens. So you never know what can happen. Always be safe. Safety glasses are a good choice. Alright, what I'm going to do on this one is just a straight cut method. I've done multiple methods, especially on my inch and 5/8, where you guys have been able to see me do some, I guess I would say, pretty neat stuff. I wouldn't not try to toot my own horn or anything, but there's definitely multiple ways to do this. And I did an outer wrap setup on a inch and 5/8. Y'all can go back and watch it if y'all want to see it. This is just another way to do this. Alright, so this braid again can fit inside here. I flared it out, and what I'm going to do is close that flare up now that I've done this. You can use any tool you want. They have what's called a hex crimp, and a hex crimp closes around the outer core of the wire itself in an even fashion, and there are a lot of times accompanied with a hydraulic press and everything else. So the reason I'm closing it up is, one, so I don't have to deal with it, and two, so that I can keep it in a specific spot that I want it. It's not really for the crimp, it's just so that I have complete connection on the outside of the wire, because it was just a hair more flared than I needed it to be whenever I flared it out. Alright, so that's just because I didn't want to have to deal with any strands. So from here, you can do any method you want. Again, in this situation, I'm going to be heating up the copper as fast as I can, because the hotter you get this center conductor, the hotter you get it down the jacket, and the faster this center conductor will get weak. So the last thing you want to do is heat it up slowly. I'll go ahead and just give you that little hint, especially when you're working with stuff like this. One thing I am going to do, though, is get this out of my lap. I'm just putting it in front of me, just so the solder hitting me. Alright, so if you look pretty close, I'm not sure if you guys can see, but if you look right around the edge, that inner conductor itself is starting to melt slightly. So what I have to do is watch and take great care not to have any more heat than I have to right there, or else what's going to happen is my center conductor is going to move over and I will jeopardize my dielectric strength. So then you defeated the entire purpose of using a bigger wire. You've literally just weakened the wire to the point where it's weaker than the wire you just upgraded from. So keep that in mind, watch out for stuff like that, and just make sure if you're doing stuff like this, you use just, I guess as much common sense as possible. That's not necessarily a common sense thing, it's more along the lines of an experience thing. So I'm just trying to save somebody who does this themselves a little bit of heartache, so because it can easily cost you a connector or cost you a little bit more depending on what kind of protections your box has got. What I'm going to do from here is same situation. I'm just going to have to watch out for the center conductor right here. And I'm perfectly fine with whatever extra I have wicking around the outside of the jacket. There's not much you can do about that. You can get a stripper tool, but there's really absolutely no point if you're doing custom connections. Stripper tools only work for specific applications. Say like if you wanted to get one for 1 5/8. Well, at that point, then you can only work with what's called a positive stop 1 5/8 connection. Well, that may be great if you have positive stop connections, but if you have say an L-type connection, like say one of these, then the stripping tool you just bought is absolutely worthless. So you can't even use it. So don't get too wrapped up in the stripper tool stuff, because then you have to get one specific for each application, and I don't necessarily have the ability to show all of you guys all those stripper tools, I don't want to show you guys all those stripper tools, because the last thing I want to do is say that you've got a whole connection that I can build for you, or that you can build, and you can build it yourself, but you just got to buy this $260 gripper tool for this one application. So I don't want you guys to kind of look at this stuff as out of reach. I want to kind of make it a little bit more attainable rather than something that looks impossible. So that's kind of what I'm doing. That's why you see this. What I did right there was just literally preheated my connection as quickly as I could. So again, I don't have the same problem as before. And that's what all the prep came around to. So doing it this way allowed me to bond my connection as quickly as possible while not sacrificing my inner conductor. I am kind of adding a little bit more heat just because I want to be more picky, but technically I'm done at this point. And then I can see what I got over here, knock it off. I can see what I got over here and knock it off, just because I'm being picky. Alright, that's the quick and easy method for a lot of you guys. The main benefit of this method right here that I just showed you was a good bond to the center conductor, and then also at the same time you have to of course make sure you're not compromising your dielectric strength. That just make sure you don't have too much heat on that center conductor, because a lot of these other methods, if you're not using the proper care, that's not too hot, but I might as well show you this way. If you're not using the proper care, that center conductor is just going to move on you by either overheating the outer shield or overheating the inner conductor. So that's just kind of another method. So hopefully that helps you guys a little bit. That's got one method done. Let's see if I got some more of my big heat shrink to show you guys. I may have to grab some, but we'll see. Got some other connectors. I've got a gigantic mess on my bench, so you guys have to bear with me for this. I've got my center conductor piece. I've got my marker. That was not the one I needed. My biggest one is, there it is. Sitting right in front of me. Let's see if I can make this one work. I can't remember for sure. There comes a limit to what I can use on this stuff. I believe this is the one I used last time, and we will see in just a moment. Take a look. Here we go. And success. This is a glue lined heat shrink, and also it's a more than a 4-to-1 heat shrink, so it means it can shrink down to less than a quarter of its original size. I don't really need it to do that in this application. I'm really using it for the adhesive liner. It just gives me a little bit more of a bite on my connection. I've got to find one more. I'm just gonna have to mark it. I guess I'm out. What I do a lot of times is I'll have a pink heat shrink for the center conductor and a black heat shrink for the outer conductor. What I'm going to do is just use a little black marker on the outer conductor. Whatever. I even turned it off too. A little piece of plastic got burnt onto my soldering iron. So, quick and easy method for getting that off is literally just using a knife. Alright. So, first method, go ahead and cut. My scissors are here. Alright, so when you're working with heat shrink, the biggest thing you got to watch out for is just making your heat shrink too long. If you make your heat shrink too long, then what will happen is it will start to bind as you're wrapping it or as you're sliding it through, and then you won't be able to get it slid all the way down your jacket. And in case anybody asked, I'll show y'all again. I do have a heat gun. I do not use one because they do not they take too long. If you've seen me with a heat gun, I think I showed an example one time. It took me about triple the amount of time to heat shrink the same connector or connection. So, you want to use a heat gun, feel free. I will not on my big stuff. It's just not worth the time that it takes. This is probably the easiest wire to heat shrink, or excuse me, to use the heat gun on. But when you get to this adhesive line 4-to-1, it's ridiculous. Not just slightly annoying. It's just nobody's got 5 minutes to sit there and heat shrink one connection. Alright, so since this will be difficult for some, what I'm going to do is put a little marker on it. This is just a marker to mark which one, denote which one's the shield, which one's the center conductor. It doesn't really matter. It's just for the customer. So if the customer can't see where it goes, or doesn't know, or has difficulty, this right here will give them that reassurance that they've got the right connection. Alright, so if you look, there's always a very simple way to figure out which one's which. If you look, there's one that's lined up directly with a center linear, well, straight in proportion with a coax. That's always going to be your center conductor. The one that goes around the outside or follows an outer path is always the shield. So it doesn't matter if I do a wrap style heat shield or if I do a straight connection style steel shield like I did on this one. Either one comes out with the same result. Oh goodness. I might as well go ahead and get this ready. Got some juice. Take me a minute to do that. So you can use whatever material you want for your center, basically for your weatherproofing. That's really personal preference. For some reason, I've seemed to like just regular, or not regular, but more higher grade hot glue. It just seems like it wicks in and grabs what I need it to grab and does what I need it to do. You can use silicone, you can use silicone too, you can use any other non-conductive style center conductor, or excuse me, not center conductor, insulator. It's just weather sealant, it's not doing anything else. If it doesn't have a high dielectric strength, then of course you can cause problems with that, so just keep that in mind. What I'm doing is keeping this connection and this connection separate as it goes out, so I'm not have to worry about it. So, put it up here. Now, I could continue further, but that defeats the whole purpose of what I'm about to do. So, yeah, I have plenty of black heat shrink. I've got about 200 foot of it, but it's not here. So, you can use black heat shrink for that. That's just denoting which one's which. Alright. I have heat shrink that's about this big around, but it's just not here. I don't need it for this specific application though. So. Alright, it's got to get a little hotter, so I'll wait. That pretty much concludes the direct feed style connection over here. LC's coming next. We'll probably just go ahead and do it just because it's here. I don't really know what time it is or how long I've been on here, so if y'all guys want to hang out, what I'm going to be doing next is this right here. So in case any of you guys don't know what the other end looks like, that's the other end. Goes to a bird meter. So LC. Not really much to this part right here. Just a bunch of working on this. Oh, nice. Oh, is that low? And you'll see it kind of build up to the outside as I shrink this down. Alright, and then from here, all I've got to do is that little bubble on the outside, I'll just clear it out, and that's it. Alright, so I could use a tool. I could use my knife right here, just wipe it along the edge, and then of course just wipe it off or whatever. All I'm trying to do is just stop this little spider seal from going on. If you look, it'll make a nice little stringy, really annoying little attachment if you're not careful. So that's why I make sure to press against it the way I do. I've got to wait a few minutes for this to set, so I can kind of just set it somewhere. I will not be able to. I'll do this. This connection doesn't really matter as much. It's done what it needs to do. Let's shrink this down real quick. There we go. I wanted to see that. So, it requires me to do this one more time. Really annoying, but it is what it is. So, y'all can kind of see the extent of the stringy mess. There was something that was bothering me on that connection. I wanted to see it bond all the way around, so that connection is the way I want it to be from there. So it's kind of the gist of that. I've got it tied down where I want it, so I'm going to try to see if I can get this other connection. Y'all aren't aware what I'm working on. That's what it looks like right there. So, other end that I'm going to be getting to is on the opposite end. Right here. So. Wish I didn't have to do that one. Whatever. Not treat those after. So. If I can keep this form up without taking too much off, then what I can do is I can also use this for a shipping wrap. So, now, or excuse me, the beginnings of a shipping wrap. That's definitely not a completed shipping wrap. There's more that's got to be done. Alright, so see if I got enough, and check on this piece over here and get it out of the way. Oh. Alright, connections over there is fine. Y'all can see a little bit of a mess back there, but hey, it is what it is. Sometimes you gotta do what you gotta do. Alright, so unwrap you. Okay, next. Alright, let's get that flared. So, I suppose I'll. Wish I could show y'all. No, can't show y'all here. Maybe. Yeah, there's just some old ones right there. So, basically all I'm doing here is this is what this is going to look like when I'm finished. You'll have the center conductor right here, and that goes in there. So the center conductor goes in here, and then shield couples around the outside. So, alright, so first things first, I'm going to check and see if I've got a flush cut over the end, and I do not, so it's not straight. So what I'm going to do is straighten that cut out real quick with my Dremel. You can use any other tool you want. I've got it, like I said, I showed y'all another cutting method with the 1 5/8 the other day. I've got a Dremel here, so I just use it. Hey. Now let's see how straight I did it. Alright, I got a mess. Wipe it off. I hit it for myself. If you cut wrong to begin with, it's better to cut less than it is to cut more, because all you got to do is just recut the jacket. So if you screw up altogether, just start over. I say that on my 1 5/8 ones, and I will definitely say that on my 7/8 ones. And don't think you have to be perfect, especially if you're doing this the first time or second time, or I don't care how many times you've done it. Everybody can screw up. Alright, so I need to cut, let's cut a little bit bigger. So, I can stop right where I was at, but I want to add a piece. And if you buy these connectors new, which most of you guys won't, because a lot of this stuff is really new old stock and you'd really have to kind of do some digging to find it. A lot of times they'll give you like a little manual to go by, and you can follow that. I'd kind of let's say modify it a bit on a lot of mine, just because if there's a better way to make contact, especially on a connector, then I will definitely take that method. Like on my 1/2 inch flex, I actually use a different connector than what they recommend, because I like to get I need to look at this real quick. Because I like to use a different piece than what they use. They don't really have a tight specific piece. And what? Close to the flange. Aha! There we go. Got what I need, and where's my toys? The little pieces are hiding somewhere. Bear with me. Like I said, I have a terribly messy bench right now. Alright. Really doesn't matter if you use these. They're more important for outdoor use. Indoor use, unless you're going to be constantly trying to submerge them in water or something, then you should be fairly fine without them. All it is just O-ring seal. You get to put one around your center conductor, which is this one. Run it down towards the bottom, seals off the base, and then you can do your other on this one. I forgot what the heck you put this one. You've got this one around the base, and this one goes along the outer edge of this piece right here. There you go. Had a quick brain fart for that second. What it does just goes around that outer edge right there. Alright, so from here I'm going to have to clean this connection out. I'm going to have to flare that. I'm going to have to solder this, and that'll have most of what I need from here. If y'all been asking me questions, I do apologize because I have not been looking. If y'all have not, then sit back and enjoy, because that's, I mean, some people enjoy just watching this stuff, so y'all feel free. I've got to build it anyway, so I figure I might as well share. And any of you who watch my videos, y'all know I say that quite a bit. Oh no. Alright, so from here, didn't really explain much, but that's just a method for cleaning out this connection. Also, a easy method for dealing with a lot of connections on here is use the lubricant that comes with the stuff. It comes in handy. I've found situations where I had a really tough time with the connector just because I didn't use something, and then either my O-ring broke loose and got ate into, or it was just really tough dealing with the connection. So I realized that not all methods are a negative. Alright. So from here, this is just to re-get my bike. You can do whatever method you want. I'm just making sure it clamps the way I want it to on this wire.
You still have that video on?
Hush. If you want to sit and watch, you can watch.
Can I just play in Fireflies?
Go ask Mommy. Alright, what I'm doing right here is flaring this connection out. Oh, I can't show y'all my little firefly holder for the kids last time. My little helpers are not doing much helping tonight, but I don't need them too much. So what I'm doing from this point is flaring this connection out so it gets a good crimp on the outer jacket, because anybody who's ever dealt with these connections know how they connect. Anybody who doesn't, flare it. Just don't question it, just flare it. All right. There's another one somewhere, but I've got 100 of these, so I'm not really too awful concerned. There it is. Alright, so I'm doing a slight inner flare on this one just because I want a good bite. It's not, if you had a good flaring tool, it'd be really nice. You could make that a really nice looking connection. I'm not really too concerned about it because what I'm about to be doing, y'all can kind of see. We got some critters out tonight and some little noisemakers. Alright, you can kind of see what I've done there. Just threading that inner conductor. Alright, from here what I do is just add heat. Hang on a second, I gotta grab a piece. Oh Lord.
What?
Come give me some. Alright. Put them on a mission. I gotta go catch me some fireflies now. Alright. Again, take extra care in how much heat you put on the stuff. I did that for a reason. Okay, so there you go. It's kind of the fun with this. Now we'll see how well of a flare I did. It doesn't take much. Did you find me any?
No.
Then sit down. Let's get on.
There's not a bunch of them.
Well, if you're gonna hang out in here, sit down.
I was so close to get them.
Good job.
But then they got away.
Uh-oh. Letting them get away. Alright. I'm being picky just because I like to be, and because, I mean, there's no reason not to be. What I'm doing is knocking that flare on that edge down so it's rounded. To try to slide this connector on. I wish it was always the fun part, because I have to make sure my flare is not blocking my connection, and I've got my crimp tightened down. This is actually I have to squeeze it. Oh, okay. That's okay. Now, you guys may not have as much difficulty as what I'm doing, because you may be doing something a little bit different than me. But this is mine, and this is how I like to do it, because I can, I guess. This is they only made a few of these connectors, and I've got to make them work for my application. Alright, so we're lined up on the heads, and all I gotta do is tighten this up. So what I'm gonna do is get the right piece that I need for this, and then I'll be done. It just shows y'all the concept. I'll kind of alright, so whenever you put this in, you've got an LC connector, and then you split screw it to your bird. There you go. I've done this video for long enough, and I've spent enough time out here, so I am sufficiently tired, and I'll finish this up a little bit later. I've got to finish this. I've got to finish some grounds. I've got some 1/4-inch flex done right here. It's got a dent on one end, and then it's got a dent right angle on the other. Shipped out another 150 foot of inch and flex, half-inch flex over the weekend, some 1 5/8 last week, and I've got a few more connectors and another braid and a few other things to do this week, and then I'll be done. So that's kind of it for the night. I'm gonna finish up. All I've got to do, I'm gonna pull this back off, tighten it up one more time, and then thread it on, and I'll be done. Just like my other LC, they're always fun. Would not be a connector I would recommend for a customer. Something I would recommend for a customer, especially one who's not super experienced, is one of these over here. One of these. This one's probably, I guess, what you'd call an entry-level connector. It's just a 7/8 for or 7/16 in for 7/8. If you're ever trying to build anything with 7/8 and you want to try something that's going to be fairly easy for you to start with, that's what you start with. LC would be for somebody who's built quite a few connectors. All right, guys, I'll catch y'all later. It depends on which ones you want. Eric, just give me a shout. Send a message to this page. I'll send you a link to a few of the ones I got. I got probably 30 some odd batteries here, so depends on what you want. I'll give you some prices. As of right now, you're probably going to get the best price you could ever get from me, just because I'm in the process of working on something and building bench number 5. Bench number 5 is going to be the most expensive bench for me to build, so, and it's going to be the final bench whenever I'm finally done. So if you want to get something from me, definitely feel free to shoot me a message on here, and I'll let you know It depends on what size you want. Like I said, I got them on 100 amp hours, I got them on 155 amp hours, 170 amp hours, 190 amp hours. And I've even got some, I think 100 amp hours right there. So depends on which company you want. Like I said, North Star, I've got them in 100 and 190, and I think that's what I got the most. All right, catch you guys later. You'll have a good weekend, or you'll have a good evening and a good week. And I'll probably catch y'all out here tomorrow or the next day for me to finish up the last of what I got going on. See y'all.